What's going on, everybody, and welcome to part 2 of our TensorFlow.js series. In this video, what we're going to be doing is showing how you can begin to incorporate TensorFlow.js into an otherwise, non-deep learning application. So this one, we're going to try to keep it as simple as possible, especially before we get into the next example, which is going to be quite a bit more complex. So all we're going to do is we're going to take input from a user, and the idea is to graph the input from the user, but also to use deep learning to calculate a best fit line. So just do regression, kind of like what we did before, only now more in an application sense rather than trying to do it all in the console. So I don't know what the most popular charting application is in JavaScript. I personally use HighCharts. I was trying to find something a little more simplistic, so I'm going to go with chart.js. Feel free to use whatever your favorite charting application is. You don't have to go this route. It really shouldn't matter. You should be able to take what you learn here and apply it to whatever you want. So anyways, if you hit Get Started and then come down to click Get Started again, you can see these script tags. Basically, we just need to copy these into our code. And the way that this is going to work is it uses canvas, so it plots to the canvas. I'm also going to copy that, paste that in here because we're going to need that soon enough. Once you have the canvas, I'm just going to copy it from the text-based version of this tutorial. I'll put a link in the description, but you can also see here kind of how this stuff works. It just takes in, it's going to populate your canvas here, and then what it's going to do is it's going to populate that with this code here. So this just defines your chart, this modifies your chart. In this case, here's a line graph. The labels here are going to be your x-axis, and data is your y. So pretty simple charting, so that's why I picked it. But again, if you want to use something else, have at it. Now, what we need first is to allow the user to actually make inputs. So the way that we're going to do that is with the input tag. So we're going to say input, and in this case, we'll say type equals number, and that just forces the user to enter a number. They can't enter a letter if they try to. And then we're going to give an ID for X, and then we're going to do the exact same thing with the Y. So copy, paste, and Y. And then I'm going to say X colon, Y colon. And then once the user inputs some information, we want to let them actually be able to submit it. So the next thing here is just going to be type button. ID will be append, because when they hit the submit button, we're going to append the new data in. And then value, what's the button basically just say? We're going to have it say submit. So let's go ahead and save that. And we are going to run it as soon as I figure out what window I have it in. I guess I just opened a new one. So here we go. And I'm going to go ahead and open the console just in case we do hit some issues. Okay, 1, 2, great. Okay, cool. So we've got our submit button, but right now, obviously, like submitting isn't actually doing anything at all for us. So coming on down here, the canvas, what we're going to do first, like let me put this into div tags just so that it doesn't run off the page. Div, we'll say style. We'll give it a padding of 50 pixels. Tab that over. Close off the div, and then the canvas will be for the chart. We're going to say the width equals 600. And the height will equal 300. All right. So once we've made it to this point, we actually have all the HTML stuff that we need. Interestingly, why are these down here? Could someone tell me why? What are these doing down there? Why are they down there? What the heck? Why is that happening? Because this is below it. Why are these down here? I have a feeling that we're going to find out later what's going on. Unless I just didn't save it. Let's try again. Okay. Weird. All right. JavaScript. HTML. Awesome. All right. So now we need the actual JavaScript to start handling all of this HTML. So script. And the first thing is we're going to say var x's is just an empty array. Var y's is also going to be an empty array. And then what we want to do is basically the way that chart.js works, at least, is the order that you submit things is how it's going to be graphed. So it's not going to it's not going to like sort the x's to be in like chronological order. It's not going to do that. So what we want to do is just kind of suggest the chronological order. So I'm going to go ahead and just set an initial value. So it's going to be document.getElement by ID. We're going to get x, and then what we want to do is we're going to say .value equals 1. So we're just going to set the value to 1 immediately on page load. So if we save that, whoops, why? Oh, okay, we probably need to put this in quotes. Let's try again. All right, so we got a 1. Great. All right, let me make this bigger too, so hopefully everybody can see. Okay, so we set that to 1 immediately. Now what we want to do is we want to handle for when. So like after that's set to 1, they're going to set y. Then they want to hit the submit button. Right now the submit button does nothing. So what do we need to do? Well, we need to handle for that. So we're going to say document.getElement by ID. What's the ID? Well, append. So when someone hits that thing with append, what do we want to do? Well, on click of the append, we want to run function params and the function itself. So what's the function we want to run? Well, we want to say the variable x. We want to say basically we want to grab those values. So we want to say var x equals document.getElement by ID x dot value. Sorry, I think I just do dot value there. And then we want to do the exact same thing to y. So I'll just copy, paste, change this to y, this to y. So now we've got our var x, our var y. And then we're going to say x's dot push x, y's dot push y. What is happening? Y. Someone tell me, when is a semicolon required in JavaScript? I don't actually know. I just kind of throw them at everything. I don't really think it's actually required here. Is it like just when you... I really don't know. Like, what is it, just for functions maybe? I don't know. Anyway, so we've got our so we're going to populate or begin to append to the x's and y's every time. Let's go ahead and save that. Let me run this real quick. On click. Dot on click. Do we say okay? So I'm just used to Python. So dot on click. That way. Save. Run. 3. Great. 4. And then we should. Yes. Cool. So now we can just say x's, y's, and we should get some values for them. Okay, so everything is working as intended so far. The other thing is, like I said, we kind of want to encourage people to really probably not modify x's at all. We just want to auto increment the x. So the next thing that we could say is we're just going to copy this, paste, and rather than setting it to 1, what we can actually say is parse int x plus 1. Because right now, for whatever reason, it even looks at here, they're a string form, which is kind of silly. So we're just converting that. So now, every time they hit the submit, hopefully that goes up 3. Yeah, okay, 32, 3. Okay, cool. All right. So now that we have that going on, we're ready to do the chart part. And I think for the chart part, I'm just going to copy and paste that in because I don't really see any benefit for us writing that one out. So basically all the way up to here, paste. I'm going to tab, and then tab all this. Cool. Okay, so all we added here is like this stuff. Okay, so we define the chart, and then we modify the chart. It's a line graph. The options here are just to make sure we begin at 0. These are our x's, the data set. We plot y's. Done. So let's go ahead and save that. And again, source code linked to it in the description. We're going to refresh, and now we'll just start to graph some stuff just to make sure it works. That should be animating. I'm not really sure why that doesn't animate, but I'm not going to worry about that right now. So this little error here is happening on hover. Not really sure why. Everything works as intended. It's a known issue in their GitHub, so I'm not really going to be worried about it. Okay, so now that we have that, we're ready to actually train a model and draw the best fit line. So really everything up to this point has really been more of like a JavaScript tutorial. So I hope you guys enjoyed my JavaScript tutorial. So let's add in TensorFlow.js now. So as always, we've got to define our model. Now, where ought we define the model? It's really going to depend on what your goals and objectives are. So you could either define the model every time, right? So basically, like think of it this way. If you have a model, especially on something that could wind up getting overfit, you'd probably want to define it every time this gets submitted, so the model isn't just getting like trained over and over and over and over. So like let's say every time someone clicks this function, you fit for 10 epochs. Well, if they input one more new data, that's 10 more epochs. Well, now you've trained for 20 epochs. So if you're not careful, you might wind up overfitting. So I think what's going to make the most sense for now is that we just define the model up here before, but it just really depends. So I'm going to define it here, and then we kind of toy with it at the end if I remember. So const model will be tf.sequential. Then we're going to say model.add, and we're going to add tf.layers.leaky, not capital L, leaky RELU, I think that's the way they're calling it. And then units, so it starts immediately at hidden layers. This is kind of awkward in my opinion, because you do have to specify the output layer, but you don't specify the input layer. It's kind of awkward in my opinion. Anyways, input shape :1. All right, so that's your hidden layer 1. Now let's add 2 more layers. Bang, bang. 128, we'll do 128. And then finally, this one, input shape is 128, but we're going to make it output 1 unit because we're doing regression. Also, this should be a dense layer because it's your output layer. Okay. Now, we need to add the model.compile. Model.compile. And as usual, we need a loss metric. We're going to say mean squared error. And then we need an optimizer. And for now, we're going to go with Atom again. Surprise. Okay. So we've got the model defined. Let's go ahead and save that. Let's refresh. Please, no errors, please. Okay, good, great. All right, so now we're ready to train it. And here's what's going to happen. So the model, so this will be like a really simple model, but it's still, the code will get executed faster than the model will train. Even though it'll train really fast, it's going to get executed quicker. So immediately, we do want to train on the latest data. We could add 1 here. That's totally fine. But certainly before we graph it, we need to make positive sure. We need to make certain that the model has trained. So we're going to use .then. So the way that we do that is model.fit, and we're going to fit tf.tensor x's, tf.tensor y's, and then we'll say epochs. I'm going to go with like 25 for now, just to keep it quick to run. And then we do this. Then open parentheses, go away, parameters, and then the closing parentheses, we're going to add those like down here. So in theory, closing parentheses, semicolon, then we run, but these are like your opening. So like these are open parentheses. We close the parentheses, parms. Then what do we want to run? Well, we're going to run this little function. So arrow, open curly, don't close that curly, close that curly. There. Whew. All right, now we're going to tab all this stuff over. Okay, I think we're good. I'm sorry for anybody who's like JavaScript expert out there, but this syntax starts to get really confusing to a little Python idiot like myself. So once we've done that, after we fit the model, we could calculate a best fit. Now that said, I'm going to go ahead and refresh here and just see if we're hitting any errors. And we're not yet. So great, that's good news. So now let's calculate a best fit line. So we're going to say best fit equals model.predict tf.tensor x's. And then I want to show you something curious. So I'm actually going to say tf.tensor x's dot data sync. Now, as I showed you in the previous tutorial, if you just say tf.tensor, it's kind of generic. It's not. It'll take anything. You don't have to be explicit. In this case, it is a 2D tensor, and the tensor is of the shape x's.length by 1. And if I save this, it might run. Okay, that's that hover thing. Scared me. Refresh. Let's say 2, 3. Where is our oh, we're not plotting the best fit line. Darn it. Anyway, it does run. Let's plot the best fit line next. So let me just do comma here, and we're going to add one more little data set. So copy, paste. We'll call this best fit. We define best fit here. So copy, paste best fit right up into there. We need to change the color. So we're going to say border color. And we're going to make this like a red, FF000. And then, is it background color? Background color. And this RGB alpha 111, totally opaque, or totally see-through. Anyway, I always get that screwed up. Okay, save that. Now let me run it. So 2, 3. Okay, so you get a best fit line already. So that's working. We expected that to work. Now the curious case though is, like I showed you before, you actually could, if you just say TF tensor, you don't have to give the shape, right? Right? Save. Refresh. 2. Oh my goodness. Why? It doesn't make any sense to me. I'm not really sure why that happens, right? It says it got an array with shape 1, but it's expecting 2 dimensions. I don't know. It should be able to figure that out, but it can't. I think that's a bug. I might be wrong, but we can just specify the shape. So again, it's just x's dot length by 1. So you can just throw in the shape and things work again. Nice best fit line. Oh my gosh. Wow, really? You just really want to fight me on this one, don't you? Really? Dude. How many times do you think it would take? Yeah, it just doesn't want to train. Interesting. So that could be one example of, like, if we redefined that, we wouldn't see this problem anymore, but for some reason it really wants to stick down there. Interesting. Okay, so I just want to say the tutorial is basically over, but there is one more curious case. Let me just refresh this, and let's redefine the model every time the button is clicked. So I'll just copy and paste that down here. Just so hopefully we'll get something a little more reliable than what just happened now. 5. What? Hold up. Why does this keep happening? Interesting. Maybe it's the epochs. Where's our, let's see, it should be, we really shouldn't have that kind of an issue this early on. I'm really trying to prove a different point right now, and this is getting in the way. Okay, I don't appreciate this oh my gosh. This is somewhat comical. Anyway, whatever. So in the live stream, some people were asking, hey man, how come, they didn't say it like that. They say, how come we have, so with a neural network, if you only have one hidden layer, a neural network can only learn linear relationships. So in a single layer neural network, pretty much no matter what you do, unless I'm mistaken in some way, no matter what you do, you're going to wind up with a straight regression line if that's what you're after. If you add more than one hidden layer, though, we can begin to learn nonlinear relationships. So the question was asked after the stream was posted, why is the best fit line a straight line? Should not it learn better? The issue is we're using leaky rectified linear, which is giving us a linear activation function. So if instead we switched to dense, which I think is still defaults to a linear activation function, let's just see. In other news, though, it does seem a little more reliable than leaky rectified linear. Anyway, it seems a little more, at least a little more legitimate. But it's still linear and not nonlinear. So what if, though, we add one more parameter, and that is for the activation. So we're going to just here activation, and we're going to add sigmoid. So any sigmoid activation will do, including sigmoid. So we'll save, rerun to 5, let's say 12. I'm a little bothered at the moment. TensorFlow.js is not working with me today. Okay, so there is a curve there. It's just very, very slight. We should see a more dramatic curve than we are. It must be our learning rate. Okay, let me visit the docs real quick. TensorFlow.js. Bang. API reference. What I'm looking for is, let's change the optimizer. Just take me to optimizer, you get doofus. No, that's not what I wanted. That's not what I wanted. No. Let's see. I found it initially and then I went away from it. Anyway, optimizers, okay. Okay, yeah, we'll take this. So copy that. We're gonna come over here. Yeah, above here. So basically above, so before we say optimizer atom, instead we're gonna say const optimizer equals tf.train.atom, and then give it a learning rate of like 1e-3. So I'm gonna get rid of this. I'm gonna hopefully not knock over my coffee, and then we'll take the optimizer here, paste. Optimizer is optimizer, great. Logic, refresh. Now let's do 2, 15, 3. Really? 15? Are you kidding me? I think we're doing 150 epochs. That should do it, man. That should be pretty darn good. We could go with this. I really think we've got enough. Hmm. I would really expect it to learn a little better. Maybe our learning rate was too low. Man, it's better, but that's still not like a really solid fit. I would expect a better fitment. I hate to make the learning rate even bigger. We could do more epochs, I guess. Let's just double the epochs. For real, the tutorial is definitely over. Now I'm just trying to figure out how to get this to be the answers that I like. Let's do 2, 15, 3. Dude, it's just not. That's pretty close. Okay, I'm going to write home about that one. I'll take that. Anyway, that's pretty good fitment. Yeah. All right. So that is your pretty basic introduction to TensorFlow.js and combining it to a simple web application. In the next tutorial, we're going to get quite a bit more advanced. We're going to probably not be handwriting our JavaScript anymore. But what I'd like to show you guys is to basically run through the following. If we can get it to chill. This example of playing Pong against an AI that was trained to play Pong. And so this runs with TensorFlow.js, plays against you in Pong, and this requires quite a few more things. So training it in Python, transferring it over to TensorFlow.js, and then also so like loading a model and all that. And then you could also do transfer learning in TensorFlow.js to further train the model to maybe even play more like however you play or something like that. So that's the next bit of the tutorials that I'm going to show you guys. If you have questions, comments, concerns, whatever, feel free to leave them below. Otherwise, thanks as always to the sponsors and anybody else who wants to support. You can do it at pythonprogramming.net/support. Otherwise, I will see you next time.